Okay, let's look at 1.3 Part B, which is standard deviation. So we are still talking about the measures of spread. So standard deviation is the measure of the spread. In the distribution below, how far are the values from the mean or average? So we would look and see where are the dots, and then we also need to compare it to what the mean is. So what does a standard deviation measure? It's going to measure the typical distance from the mean. So the mean on this one is going to be 4. See how it's symmetric? We have a 1, we have 2 2s, a 3, a 5, 2 6s, and a 7. So let's talk about what each value is as far as the standard deviation. So 3 is 1 below the mean, so that's -1 is our standard deviation, or our deviation from the mean. 2 is -2 from the mean. 1 is -3 from the mean. 5 is 1 from the mean, and it's plus because it's above. And then 6 is 2 above the mean, and 7 is 3 above the mean. So if we average those, we end up with 0. And that really doesn't tell us anything. So what we want to do is we want to be able to use standard deviation. So there's actually a formula we're going to get to. What are some similarities and differences between the range, IQR, and deviation, standard deviation? Similarity, they all measure variability or spread. Differences, they're not all resistant to the outliers, and they don't all use all of the data. So we're going to rank standard deviation, IQR, and range from most resistant to least resistant. So let's look at that. Most resistant is IQR, which is great. It doesn't even include outliers, so it's resistant to those outliers. So that's our most resistant. The next one is the standard deviation. It's also resistant. But our least resistant is the range, because remember, to find range, you take the maximum and you subtract the minimum. So if your outliers are the max or min, then they're going to be effective. So we are not going to use that. All right, so let's again talk about standard deviation. So I have these, the same dot plot that we have above. We are going to calculate our standard deviation. So in addition to the range and the IQR, another possible way to measure the variability of a distribution is to find how far each value in the distribution is from the mean. For example, in the dot plot above, the observations are 2 units from the mean on average. So we want to actually use a formula, x minus mu. So x is the value, mu is our mean. So unfortunately, when we add up x minus mu values, we'll always get 0. So to solve this problem, we're going to square each of those deviations before adding them up. And that's going to get rid of the negative, which is going to make it where it's not a 0 anymore. Okay, so let's look at how to find standard deviation. So there are the steps. So we are going to have to actually make a table of values. Okay, so and find the standard deviation. So step 1 is find the mean. So mean is x bar, and that is 4. And it says find the deviation from mean for each data value. So each data value is going to be called our observation, or x. So our data values are, we have 1, we have a 2 2s, a 3, a 5, 2 6s, and a 7. And then we have the difference between our observation and the mean. So we're going to call that x minus x bar. So this would be 1 minus 4, which is -3. Then it'd be 2 minus 4, which is -2. The next one's the same thing. 3 minus 4, which is -1. 5 minus 4, +1. 6 minus 4 is 2, another 2. And 7 minus 4 is 3. Then we're going to square it. So I'm going to write this like that. Okay, so we have 9, 4, Okay, so then our next step, so we did step 2, we did step 3. Find the sum of the squared deviations. So we need to add those up. So go ahead and add those up. And it is 36. And then divide by n minus 1. So n is the number of values. So look at how many dots we have. 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. So we're going to divide by 7. And then it says take the square root. So this ends up being 2.3. So this is called S sub x. So standard deviation is 2.3. All right, let's go to the next slide. Okay, so here's our formula. It's exactly what we did. 1 over n minus 1. Well, instead of doing that, we could put n minus 1 down here. N is our data values. X sub I is our observations. X bar is our mean. Okay, so we have to do all of this stuff for standard deviation. So it says the average squared deviation is called the variance. Okay, so if we want the variance, it's another value, then we would take the square root. No, then we would not take the square root. We would just have 36 divided by 7, which is 5.14. That's the variance. Okay, so the next one. Oh, it's there. Okay, so what are some properties of the standard deviation? So only use to measure spread when distribution is symmetric, mean is in the center, and it's always greater than 0 because remember anytime we had negatives, we squared them, so that got rid of negatives. So it's always greater than greater than 0. If it actually equals 0, then that means there's no variability, okay? So this is what goes with that. But it's always greater than 0, greater than or equal to 0. But if it's exactly 0, there's no variability. All data values are the same. And we also need to make sure we use the same unit of measure as the original observation. So if it's inches, then we use inches. If it is centimeters, if it's hours, whatever it is, you have to use that same unit of measure. It's not squared or anything like that. S sub x, which is our standard deviation, is not resistant to extreme measures. So if you have really large outliers, then that will not be resistant. And then standard deviation is the square root of the variance. Probably get these all down. Pause it if you need to. Let's look at this example. A random sample of 5 students was asked how many minutes they spent doing homework the previous night. Here are their responses in minutes: 0, 25, 30, 60, 90. Calculate and interpret the standard deviation. Okay, so we're going to do a table just like we did before. So step 1 is define the mean, X bar. So add up all of these and divide by how many we have, divide by 5. So go ahead and do that. And it ends up being 41. So then we take a table. So our observation, which is X, we're going to put that to the left. So 0, 25, 30, 60, and 90. Then the second column, X minus X bar. So 0 minus 41, negative 41. 25 minus 41, negative 16. 30 minus 41, negative 11. 60 minus 41, 19. And 90 minus 41. Okay. And then we take the deviation and we square it. So X minus X bar, and we square it. So negative 41 squared. And then and 16 squared, 11 squared, 19 squared, 49 squared. Then we have to find the sum. So 4,820. Okay, so remember we have standard deviation. Here's our notation for it. We do the formula. So it's 1, n minus 1, so n is 5, so 5 minus 1, and then times deviation squared, which is 1205. So just something out to that, go ahead and write variance, 1,205. Then when you take the square root, you get standard deviation, 34.7. And our units are the same as our original observation, so minutes. So we calculated the standard deviation. Another step though, it says interpret. So let's interpret the amount of time spent on homework typically varies by 34.7 minutes from, so you have to give us some relation to this problem, so from the mean value. The mean time of 41 minutes. So we calculated and interpreted. So remember, we have to do this with context in mind. Okay, so we have the calculator that we can use in order to find our standard deviation. So step 1 is to enter the data into L1, find the summary statistics. So we go stat, calc, one variable statistics, and we want to make sure we're using L1 if that's where our list is. And then we will look for S of X is our sample standard deviation. And then a Greek letter, population. Let me double check what that word, population standard deviation symbol. It is sigma. Just wanted to make sure I said it right. This is the population standard deviation. Most of the time we are not going to use the population. So okay, so let's go ahead and look at this on the calculator. So I'm going to go to Stat, Edit. I have some stuff in there. So I'm going to go up, hit Clear, and go to L2. I'm also going to clear that. Clear, Enter. Clear, Enter. Clear, Enter. Clear, Enter. I don't know why it doesn't want to do it. Clear, Enter. There we go. Okay, so I'm going to put in 0, 25, 30, 60, 90. Now I'm going to get out of there, go to stat calc, one variable statistics, and it's L1. I'll leave that blank. All right. So there we go. We have our mean, x bar is 41. We have S sub x, which is our sample standard deviation, 34.7. Population, and then we have n equals 5. Then we have the rest of the 5-number summary that we've already done. Okay, so let's review the measures of when you should use certain types of measures, okay? So if you want to make this table on your paper, you can. So let's talk about measures of center. So we have mean and median. So whenever it is skewed, then we are going to use the median. When it is symmetric or normal, we're going to use the mean. And then our spread is our variability. So when it's resistant, we are going to use the IQR. We're going to do that with skewed distributions. And then non-resistant, we are going to use our standard deviation to describe variability. So measures of spread, we're talking about variability. Okay, use specific words when describing a distribution. Don't just say center or spread. Don't say the center is 10. You have to say the mean represents, or the mean is blank. The center is represented as the mean of blank. But you definitely want to use these keywords here, okay? All right, that is it for our notes.